some of my introduction.
Yes, sir.
So that you have to give elementary 2-3 lines regarding to me, and then after
Yes, sir.
I
Yes,
going
sir.
to
After
introduce myself, sir.
yes, sir. Definitely. We'll start within a few minutes, sir.
Okay, no problem. When you intimate me to start, we
Yes,
are
yes.
going to
The
start.
participants now they are joining. Once
Yes,
they
yes,
finish,
sir. Allow participant to get joined fully, sir.
yes,
No
yes.
problem.
Definitely, sir. Thank you.
Okay, sir. Okay.
Now, sir, Dr. Jani, sir,
Yes, sir.
can we start the session, sir?
Yes, sir. We definitely start. Yes, sir, I am getting joined through the guest link. My video is not available as the message display. You have to see here, sir.
No, sir, you were
There is
saying
no need of obvious video too. This message is there. You can
wait,
share
wait,
your
sir.
video when you
No, no,
done
no.
haven't done since because
We will
that is
make
the
it, sir.
rule of.
Just a minute, sir. Just.
Okay. If try done from your side, then. If sir, internet, electricity,
Sir,
anything interrupted
just
in
a minute.
between, yes, sir.
Sir, you have to switch on your video, sir. Our side, you have been in the presenter.
Yes, sir. Whenever I pressing the video, the message is you can share your video when you have done screen sharing.
Sir,
Again, I will share my screen.
can you once again log
Again,
into
I will.
rejoin?
Yes, this now video available. When I sharing my screen.
Yes, now your video is okay, sir.
Yes, yes, sir. So now this video is gone. So there is obvious, there is no need of video. As PPT
Video is
almost
needed, sir. Video is needed.
video is needed, but as I am connecting to the guest link, it is not possible. That recording has started, but this message display. You can share your video when you are done screen sharing. So again, I will have to.
Video.
So when I share the video, moment video will disappear. This is problem as I am very experienced person in the team since last 2 years. Yes, I am joining guest link. I don't have my password and all in the team, whatever may be the provided. So that kind of thing is there, sir.
Sir, if that is the case, no issue, sir. You can start the session. Let me
Okay, sir.
introduce you. Without video, you can start. But
Okay, initially I will have going to start
yeah.
so that if
Initially,
you want to record.
you can turn your video so that
Yes,
we can
yes,
have a
so
screen
that
share.
my face is available on the screen.
Yes. Now we will introduce
Yes.
you, sir. Thank you.
Okay, sir. Okay.
Good morning to one and all present here. I welcome you to the third day of the Exergy and Thermo economic investigation in power generation system conducted by Department of Mechanical Engineering, Kingston Engineering College, supported by AICT, ATAL, New Delhi. Now I call upon Mr. Sanjay Ganesh, Department of Mechanical Engineering, Kingston Engineering College, to introduce our speaker.
Thank you. I now introduce Dr. D.B.Jani, Assistant Professor, Department of Mechanical Engineering, Gujarat Technological University, Ahmedabad. Dr. D.B.Jani has obtained his UG degree in Mechanical Engineering at Bhavnagar University and his PG degree from Gujarat University. He has completed his PhD from IIT Roorkee in Thermal Engineering with his thesis titled Performance Study of Solid Desiccant Vapor Compression Hybrid Air Conditioning System. He has a variety of software exposure in MATLAB, Transys, Transbuild, Fortran, C. His research area widens upon enormous fields. Few of them are Transys, artificial neural network, thermal system and design, renewable energy technologies, solar energy systems, second law analysis of thermal system, air conditioning, refrigeration, applied thermodynamics, and energy engineering. He has been a reviewer in eminent journals around the globe, such as Journal of the Institution of Engineers, International Journal of Hydrogen Energy, International Journal of Refrigeration, the International Journal of Automotive and Mechanical Engineering, International Journal of Modeling and Simulation, and the International Journal of Exergy. Along with industry knowledge and technical software knowledge, he possesses a knowledge in interpersonal skills such as public speaking, training, university teaching, and individual counseling. Due to his vast experience and skills, his portfolio often includes Nodal Officer of Admissions, Campus Director and Security Controller, Chief Editor of Institute Newsletter, Central Purchase Committee member. He is a lifetime member of Indian Society for Technical Education, Indian Society for Heat and Mass Transfer, Indian Institution of Engineers, India. He was successful in organizing the World Conference of Applied Science, Engineering and Technology in 2018 as an organizing committee member by Institute for Engineering Research and Publication. He was appointed as Conference International Technology Committee member at ICCAE 2018 and was organized by the School of Civil Engineering and Architecture, Wuhan University of Technology in 2018. He is also appointed as Conference Organizing Committee at the Third International Conference of Energy Engineering and Environmental Protection 2018. He was appointed as Program Committee member by International Conference on Sustainable Energy and Environment Sensing for Cambridge, UK. He was an editorial board member for the AR Research Publication and Conference World, the SCIREA Journal of Mechanical Engineering. He is currently guiding 3 PhD scholars and 1 PG scholars. He has already guided 7 PG scholars. He has conducted various STTP on the topics: advances in structural and civil engineering, emerging trends in major thrust area of mechanical engineering, advances in manufacturing and automation. He has also authored the following book, titled Applications of Solar Energy, which has been published in the 2018 January. He has published nearly 56 journal papers in various national and international journals and conducted various training programs with various institutes. It is an honor, sir, to introduce such an eminent person to the participants, and I welcome you once again, Dr.Jani, sir, to this FDP session. Now, I would like to take upon Dr.Jani, sir, to share his valuable knowledge to us through the session. Thank you, sir.
Okay, thank you, Ganesh sir, for providing very detailed introduction about me. Now I'm going to share my screen. So friends, today we are going to discuss about the Exergy analysis of the HVAC systems in the power generation. As sir introduced, I have completed my PhD from IIT Roorkee in year 2070. Previously worked at very renowned institutes of the state of Gujarat. There are so many publications, reviewers, as well as another conference and research group. So today we start with the topic of HVAC system used in the power generation. So for here today, we are going to use a typical desiccant cooling kinds of the HVAC system. So before going to indulge into any research area, first and foremost questions come into the born of anyone that whether the selected researcher field having the bright future or it will get its stagnancy over to the time. As we see here in this chart and graph, you can examine initiation of research in the desiccant cooling initially started in the year 1970 and onwards. As you see here, decade by decade, there is a amelioration in the publication numbers in the field over to the time period. So it is one of the most promising research field in the area of dehumidification and cooling in the typical HVAC systems in the industry as well as for the various household applications. So before going to discuss about HVAC, we may have to come into its full form. HVAC is heating, ventilation, refrigeration, and air conditioning. So it is a sub branch of mechanical which concentrate mostly on to provide air conditioning as well as refrigeration services to the industry as well as to the society. So common man will have the idea about air conditioning is to control only the temperature. But according to the definition, air conditioning is the simultaneous control of not only to the temperature, but at the same time with the humidity as well as air cleanness, its velocity. And so far, one new term will be available nowadays is called the air purity. So most of time, whenever you read the newspapers of the Indian subcontinent, most of time Delhi and nearby area will have a very poor air quality index. So at that time, whatever may be the work aspects from the air conditioning will be highly in terms of to provide not only to the thermal comfort, but also to provide air purity to the indoor comfort. This time, as we know that it is the Corona era, where also a cleanliness of the air, you can say hygienic condition is first and foremost things of the importance. So thermal comfort basically related to the development of thermally viable environments to the human being to express his or her satisfaction to be in combining to that atmosphere. So most of time when we see that large human gathering into the small place, such as like cinema hall, some drama hall, certain exhibition hall, certain malls, where large number of product as well as people load internally to the very small area. And there are certain limitations of the conventionally used air conditioning and refrigeration devices to handle that load. In that case, we may see there are number of parameters that can affect the thermal comfort to be provided by the HVAC into this closed environment. It is a materiological, physiological, age group, activity, clothing, the people internally wear in the closed space, all that will relate greatly to the thermal comfort. So whatever may be the quantification of the term thermal comfort is not only easily to be understood by the layman person. So we may have discussed here today different aspect of the HVAC in providing cooling to the internally closed environment. So there are different applications where we are going to provide HVAC facilities, such as a hotel room. It may be auditorium. It may be a meeting room of office or some industry. It may be a small personal cabin. So at that time, different area as well as a different occupancy will be there in the particular application. So according to that, ASHRAE is the American Society for Heating, Refrigeration and Air Conditioning Engineers. They are the groups of people broadly related to the design, manufacturing, sales and service of all HVAC machineries. So they may provide a different standard that may go ameliorated decade by decade, year by year. So standard 62 relating to provide the ventilator airflow. So ventilation airflow is the flash outside air supply to indoor environment for to provide fresh oxygen to create a hygienic conditions to the internal occupants, which will be in the large number. So that standard to be given out by the ASHRAE in 1981 gets ameliorated to the year 2001 by some percentage increase in its previously determined ventilation airflow, which measured typically in liter per second per person. How many persons in there in the closed occupancy should have different liters per second of airflow to be required as a ventilation airflow. Normally in our household applications, typically these days we may use a split air conditioner. So one of the limitation of the split air conditioners is they may not provide you any fresh air. If you open the door partially by in and out during door opening hours to be designed for the system, or either open your windows slightly 2 to 5% to make exchange of air in between. So this ventilation airflow is necessary to provide the fresh oxygen. The air standard not only to require just the cooling air, its temperature. Normally we see that in air conditioning, temperature aspect to be controlled to the 25 degrees centigrade and humidity is 50%. So number of experiment conducted by various scientists and researchers previously to conclude that value. So this is universally accepted for the different continents, for the different peoples. That is the very generalized value. So far, to maintain air quality index, we may have to provide oxygen. And so always there be ventilation, airflow is there. In our conventionally used split AC does not provide anti-ventilation airflow. One pipe that will connecting indoor to outdoor unit is only the refrigerant to flow in and flow out. But if instead we may not open the door and window and to be sit inside the room which is closed 100%, typically for more than 10 hours, it causes serious effect over to the health of people because of lacking in oxygen. So that ventilation airflow should be there whenever a particular HVAC system as per requirement and design standard of SRA to be formulated. So suppose we have to take here example of hotel room. In earlier case, 1981, it is to be suggested 7.5 liters per second, but that can get ameliorated in 2001 by 15 liter per second. Similarly, for small cabin, it is 2.5 liter per second, gets ameliorated to 10 liter per second. So it is a 400% increase in the ventilation airflow requirement per person in terms of liter per second. Which are the reasons for that appellation? Day by day, as you know, that greeneries over to the earth planet get vanished. So far, the trees and some plantation which will provide fresh air, its number will decrease day by day. Certain fire and etc. Things available in Amazon forest too will reduce the capacity of this earth to convert carbon dioxide into oxygen by the necessary tea plantation. So day by day, atmosphere of outdoor air get deteriorated because of global warming. Temperature may rise. Yesterday, I will have read a newspaper and some report has to be published by NASA, as you read today's newspaper, that most of the district and countries situated to the seabank get immersed into 3 feet water into the next 17 years. So it is the great threat to the environment for to keep minimum production of carbon and global warming to be the minimum. In olden days, wherever you using vapor compression kinds of thing, there is a lot more use of a chlorofluorocarbon. That is one of the main culprit for the ozone layer depletion and responsible for global warming. So if we come to the old history of cooling, so that is the evaporative cooling. Cooling process gets originated with thermodynamics of evaporative cooling. Yeah, thermodynamically, evaporative cooling is endothermic process. For water to evaporate below its saturation point, you may have to provide a certain heat so that that water may get evaporated and during evaporation can extract the heat from its surrounding, and so far remaining air gets cooled. So far certain water itself get losses in form of evaporation. So suppose you provide the temperature 35 at the end of evaporator, whenever humidity is very much below to its saturation, will get temperature difference by the evaporation of cooling around 8 to 10 degrees centigrade. In the case of a hot summer, it will be very much thermal comfort for the occupants in an indoor environment. But there is one of the limitation of this evaporative cooling. Evaporative cooling can be do its work better whenever the humidity is very less. Wherever humidity is very much nearer to its saturation state, at that time the evaporation process efficiency goes drastically down, so that effectiveness of evaporative cooler by its climatic applicability in the regions like Seashore, Chennai, Bombay, Thiruvananthapuram, etc. regions which is very nearer to seashore gets its effectiveness too much less because of its poor evaporation. At that time, there is some advancement in the cooling by the initiation of one scientist called Carrier who to invent vapor compression based system. So in vapor compression based system is known as a mechanical cooling. One component compressor is required. Whenever you flow some refrigerants having their boiling point much below to the ambient condition, gets absorbed its heat by the process of latent heat of vaporization. So nearby surrounding, whether it is water, fluids, or etc., thing in a closed space gets cooled, reduce its temperature, and that vapor available at the end of evaporator at a low pressure gets compressed in the compressor above its condensing point saturation temperature and pressure. So for its operation of compressor, we may require electricity, and electricity will be generated in the fossil fuel kinds of most of power plant available in the India. So ultimately, for process of cooling and comforting, you may have burn more carbon, and more carbon generation will be there in the atmosphere. That will disturb the atmosphere by the process of global warming, and ultimately the temperature of earth may go on increasing 1 degree, 1.5 degree, 2 degree in the hot summer, and that may increase the further load onto the coolers. So the use of this vapor compression based system is not a sustainable use. Whatever may be energy you are consuming, there is the high grade energy conversion of heat to work, and that to the electricity, and that electricity in a secondary form may be consumed, so that it is responsible for further load added on the earth for its working to be increased. And one more thing is that it consumes too much energy for its cooling. Compressor will running almost 6, 7, 8 hours, depending upon it 24 hours load, so that much electricity may be consumed. For single refrigerator and single air conditioner in the house can provide you the electricity bill around 2,000 rupees per month. So that is a very great cost to the occupant. So there is a need to search any HVAC system that can make the sustainable use of energy. Whatever may be the two kinds of primary and conventional cooling system we discussed will be the evaporative cooling as well as the vapor compression based conventional cooling. Both of them have their limitations. In vapor compression based system, it cools the temperature, it's okay at a particular value to be above 15, but in the process of removing the humidity, as I mentioned earlier in the definition of refrigeration, that it is the simultaneous control of not only to temperature. Layman having a refrigeration and air conditioning means temperature, but whenever typical applications will be for air conditioning, it's to have a maintain humidity also, and that humidity must be with 50%. If humidity is greater, then it should be reduced, and if that humidity is lower, should be increased. So for particular season, slight variations to be allowed from 45 to 55%. So air conditioning in a process of removing the humidity, the way that used in the conventional vapor compression system is to cool the air below its dew point. So dew point is the temperature when you cool the air around the temperature 10 degree, 5 degree at particular saturation temperature and pressure will remove the humidity by liquefaction of vapor into the water, and then water due to its gravity can be separates out from the flow of air. So number of times whenever you go to ATM for drawing your money, you find some slippery areas. They may be the leaking faulty water from the drain pipe. That water is not from outside, but internally condensed the water in a process of removing the humidity. So one of the great limitation of the vapor compression system is how the humidity can be removed. In process of removing the humidity, we may have to have a great compression ratio at compressor and a very low evaporating point at evaporator to maintain the surface cold temperature around 5 to 10 degree to remove the water vapor in form of condensed water. So this is the limitation in that sometimes what happen in the process of removing the humidity, overcooled air will be there that may have their temperature yet supply maybe around 5 to 7 degrees. That is very low for the applicant. In that case, you might have to provide preheating to reach its temperature to rise around 70 to 18 degrees centigrade. So at that time, you may have to expend it more energy in form of the heater, and ultimately that will disturb the COP by reducing it to its lower value. So both the system, whether evaporative have its climatic applicability, while our vapor compression based systems were inefficient when ambient humidity is very high. Typically the area where you are residing over to the Chennai, almost all days of the year having humidity in the range above 80, 85 in summer, or June or this August, humidity may be above 90%. So that is too much for the concerning to the health of human. In the coming slide, we may have to see that. What is the way and how the conventional HVAC can remove the humidity and temperature? So this is a one tool or chart called the psychrometric chart. So as you see here, some of the blue lines, it represent first cooling sensibly to the air, and then at saturation condition, humidity in air partially be condensed and removed in form of water to make it air dry, to reduce its humidity. And at the further stage, the same is to be reheated if overcooling will occur. So there are a number of ways how can we control the RH of air. So either by heating, we can heat the air, its RH gets drastically drops down. If we cool
Hello, sir. Your volume is not audible, sir.
sir, hello sir, please reply. Some
Yes, sir.
interruption is
Continue,
there.
sir. Continue,
Okay,
sir.
okay, I will be continue now. Okay. So
Share
far,
your, share your PPT, sir. It is not. It
yes,
is,
again I will have to share. Again,
now,
I
now.
will.
Okay, sir. It is fine. You can continue, sir.
So some of the typical applications where you can say some five-star hotel or some big auditorium where number of rooms will be there, number of outlets will be there. At that time, we have to use a chilled water system. Instead of conveying refrigerant to each and every room, we may have provide the circulation of chilled water. So some centrally VCR system is located through which chilled water is to be available to the temperature too cold 5 to 10 degree, and then water easily conveyed with the help of pump to each and every outlet of the different rooms of compartment. So it is the easier way by saving the insulation cost, as well as to have a better conveying with the help of pump instead of circulating the same to the refrigerant to the different outlet. How its performance can get ameliorated with the heat flow versus temperature, some diagrams shown to you. So this type of system is also to be known in advance, known as a separable humidity control from temperature and humidity. Some of the well-known books are also available for the further study of the same. So some of the system may incorporate use of the solar energy, called the absorption system, desiccant system, and ejector based cooling system. So all these systems get compared over to the common scale, having the different solar regeneration temperature. It's a different COP, different working pairs of fluids to be different applications, its merits and demerits. So from the comparison we have see here, the regeneration temperature required for the desiccant cooling will be comparable, and its COP is also intermediate as well as the highest among the comparison of the different systems. So there may be the great suitability of desiccant cooling system to incorporate and integrate with the renewable solar energy. So one of the question born into the mind of every HVAC user, that is there any need to change the current conventionally used HVAC system? So yes, definitely, because conventionally used system may not be good wherever ambient humidity is high. In humid area, there may be different design and suitability of selecting the system should be required. As a general, air conditioning devices consume almost 40% of the total building energy. The current technology, conventionally used HVAC, typically with vapor compression, cannot control humidity effectively. Why not effectively? Because when humidity load is more, you might have to cool it too much to reach the dew point. And whenever you reach the dew point, compressor work as well as evaporative temperature should be drastically reduced to be low. That will increase the energy consumption as well as the COP of the system. Some health having a great concern whenever indoor humidity may go increase above some safe value and predetermined limit. Existing system having more maintenance, as it will operate to very high temperature in certain areas and very low temperature and pressure to the certain areas. First cost of the system of the conventionally used HVAC is also more because of comparable environment today. Ventilation loads cannot meet effectively. What we have take the example of a split AC conventionally used in our homes and offices, so that it's greatly affect the IAQ, that suffers in a great term. IAQ is the indoor air quality. What will be the quality of indoor air in terms of the fresh air, in terms of its cooling, in terms of its humidity range, in terms of its you can say about velocity. Some great filters should be there located. Most of time in conventional HVAC, filters get clogged after prolonged service, and it may not get and maintained properly. The infectants typically may get circulated to the indoor environment. Most of time, some fault in the drain pipe gets internal area provided in the system gets wetted. Because of its large wetted area, it increases the internal humidity, and sometimes bacterial infectants will be more. Existing system do not clean the environment, but it can circulate contaminants if the filters clogged on prolonged application. Overcooling and reheating cannot make the sustainable use of energy in the vapor compression system. So most of the time, thermal comfort should be provided with some range of temperature as well as the humidity described, and that should also be predetermined by the design aspect of the SRS standard 62. And so far, it controls the temperature over to the humidity. It can also control air circulation as well as the ventilation air, and can produce the cleanliness. So now of the problem is to change the system. Now, one of the things you have borne in mind, that why typically the humidity may be required in the range of 40 to 50. Nowadays, this also you may see in this corona age. For some part of the year, you find corona to be spread in a greater way. Obvious lockdown and other things put some control over to it, but ambient and its changes in humidity also play a great role. So this graph will be produced by eminent scientists based on medical as well as HVAC combination kinds of experiment previously, and the data is published in the well-known journals. So here you see some of the infectants or as a ordinate, and whatever may be the different ranges of humidity to be start from 0% to the 100% on the FCSR. So you may see that certain areas in the graph will be darker, or you can say some contrast areas. Some areas will be in the lighter, and at the end again it will be in a contrast. So in the middle portion you find light areas which can set some range by yellowing that bar is called the optimal range of maintenance of the humidity. So wherever you start from zero humidity to reach up to 40% humidity, the continuously value of infectants get diminishes. Again, if you crossing the value 60% to reach it to above the 19 and to reach 100, is again the contrast will increases. So more infectant will be prone to get dilute the atmosphere by its infectants. So this is also a similar chart show. Starting to reach to the middle, the humidity infectants propagation will getting milder and milder. So again, wherever you put its middle to the end, the propagation will be in a stronger region. So for in between some fixed humidity range, that propagation will be in the mild range. So that will give you the selection of humidity maintenance for to have a desiccant based cooling system that can control the humidity in an effective way. This is how conventionally we can produce cooling with the help of some chillers, and we are not describing the function of each component, as well as it is concerning to our BTech and MTech syllabus. So as from the graph, day by day, you see that number of units in application as far as earth temperature and severe coming summers will go on increasing. So annual growth go on increasing, number of units will be there. In olden days, air conditioner will be the luxury items and some necessity for the medical in hospital. But nowadays, a medieval man can also be able to sustain the cost of air conditioner because of its competency. So this is a very important diagram that can explain us about the working of conventional cooling as well as working of desiccant cooling. So first of all, we may have to go through conventional cooling. Ambient air, if it will be an open system, can be taken out, and it gets cooling in the cooling coil. So sometimes what happens in aiming of dehumidification, we may drops down its dew point temperature by maintaining the surface coil evaporator temperature to the very low value. So supply air reach to a overcooling. So again, you may provide reheating and supply to a typical design conditions to the test room. The same operations by the state point 1, 2, and 3 can get explain you its working on the psychrometric chart. Now our desiccant cooling. In desiccant cooling, you see that cooling coil may be used, but that cooling coil is not necessary to be used only VCR, only contacted type evaporator, non-contacted evaporator. There may be a diversified value and its application according to the need and requirement. If humidity and temperature to be required very low or fast, then you may go for the mechanical cooling. Otherwise, ordinary cooling will play its role to sustain a given temperature range. Typically, the desiccant cooler in the system will be made from matrix that can get lined with some chemicals known as desiccant materials. So suppose we talk about what do you mean and by explaining to the refrigerants. So refrigerant can be a special group of chemicals having their boiling point very much low as compared to the normal temperature. Suppose we talk about ammonia as the refrigerant, it will control the temperature around, we can say, 33 degree to its boiling point. At minus 33, ammonia will get convert its liquid to vapor form. But if you want to store it to the ambient pressure and temperature, we may have to raise its pressure to rise the boiling points above normal atmospheric ambient conditions. So this is its property is a very low boiling point. Similar, the desiccants are the kinds of chemicals or either the materials having the affinity with the water, and there is also a reason why they have the affinity with the water. In its dry condition, the surface vapor pressure of the desiccant will be very low. You may have idea that about the partial pressure law of Dalton's. Dalton performed the experiment over to the mixture of gases and conclude that whatever may be the total pressure among the various mixture of gases will be equal to individual pressure exerted by the gases itself. So if some part or some gases will be dominant in its proportion, in its pressure, then it will dominant factor in the overall pressure of the mixture. So desiccant generally are the chemicals having its surface vapor pressure to be low. So generally wherever moisture mixture or proportion of water vapor in air increases, it increases the partial pressure of water vapor in the air. So far it's resulted to higher vapor pressure. So I will give you suppose one example that some person inflated some balloon with our mouth pressure, we can increase internal pressure, and when we relieve the neck from our fingers, internal pressure can get relieved and try to get its equilibrium state with the atmospheric pressure and temperature conditions. So always the pressure itself try to reach to high value to low value, or to get in equilibrium with the environment, so that whenever air laden with the moisture comes into contact with this dry desiccant, the physical phenomena called condensation, or in a better way, in a technical terms called physical adsorption can occur. What happen? Air laden with the high internal pressure of water vapor. Desiccant in its dry state will have the low vapor pressure. So it is by Dalton's law, by natural convection way, high pressure air moisture gets saturated to the surface of dry desiccant according to Dalton's law. So by nature, desiccant by its pressure variation having the affinity with the moisture, wherever you put desiccant in the high moisture region, it try to abstract out the moisture. So that desiccant is laden over to some of the matrix in the rotary wheel is called the desiccant dehumidifier. So there are also a conventional desiccant normally found to be in our house is called the salt. Salt is the natural desiccant. Obviously, its capacity will be low. So you find salt in this monsoon season to be in a paste form. Why salt is available in the paste form? Because it abstracts the surrounding moisture, and that moisture is retained with the salt and get it saturated in the paste form. Another form is the wood. Wood is also act as a natural desiccant. So wherever moisture laden ambient air coming into contact with this wood gets abstract the moisture, and wherever moisture retains to the surface of the wood, it get inflated partially. So many times during monsoon season, we may have find difficulty in closing as tightly closing our doors and windows, and that difficulty will get partially disappear wherever again humidity to be controlled in the season of winter, or you can say about this summer. This is how desiccant will react to the moisture. So most of time due to natural affinity, and that affinity, as I explained you, by the partial pressure of Dalton's law, get moisture abstract. So scientists and HVAC engineers make use of these materials as a dehumidifier, because in the uh, conventional HVAC or vapor compression based refrigeration system, most of the difficulty is to remove the moisture. Otherwise, you may not have to drop down the temperature of evaporator to be cooled to remove the moisture. Otherwise, the temperature 15 degrees, 17 degree is okay to control the surrounding recirculated air temperature coming for the supply of a comfort air. So that thing is taken care here by the use of desiccant, and the same is represent onto the psychrometric chart by the process called 1 to T, and during which most of time you find enthalpy remains to be constant theoretically, though the process is to be inclined to be an isenthalpic line theoretically, but practically a little bit some variation in enthalpy experimentally to be found. Then after, yet a state point 2, we have got the process of cooling. Process of cooling is just to remove a delta T temperature needed for the comfort. So that may be high as compared to 4 or 5 degree here in the conventional cooling. Maybe in desiccant case, you find it 15 degree to 18 degree centigrade temperature. So that then after later supply to the roof. So we get two benefits. Maintenance of low temperature at the evaporator coil will reduce drastically the work of compressor, as well as the any requirement for a heating coil. And one of the things that is a great cooling process along with the cleaning process, how it's cooling. So here integration of the desiccant dehumidifier with the conventional cooling coil may be evaporative, maybe vapor compression, maybe contact type or non-contact type. So here in desiccant, whenever air get condensed, measure of it moisture can also get condensed to its surface. So any impurities found in the water droplets directly can get settled down onto the surface of desiccant. After condensing out air onto the surface of desiccant, we may have find it to be saturated, just like our cloth to be wetted. While having removing water from the tiles, we have most of time finds of our wetted rough cloth to be saturated, so that we have cleaning it to atmosphere for its further drying. So similar functions will be required for a desiccant dehumidifier to make its drying operation, so that in the further way it can get dehumidification, so that we may have to provide the hot air to the another section of the same wheel is called the reactivation section, and the air provided for the purpose is called the reactivation air, and the process applied for the drying purpose is called the process air. So two air stream obviously at the same time instantaneously made to flow through the cross section of the wheel. Process air as well as you can say about the regeneration air. So diversified field and energy may be used for reactivating the supply process here, and that process shown as here line joining the 2-3 here in this desiccant dehumidifier reactivation line, so that sensibly we may have removed moisture from the surface of the coil. Now, which mechanism will develop the removing moisture from the surface of the coil? So here we see that very hot air is to be passed through the reactivation coil that may have a temperature around 16 to 100 degrees centigrade. So at that temperature, again, vapor pressure of the excess hot air is to be low. Then the partially saturated surface of the wheel desiccant having moisture and it's condensed from. So obvious opposite phenomena will took place. Moisture retained desiccant surface having the high vapor pressure, and hot air flow through the fluids of matrix will be available to the low vapor pressure. So reverse phenomena will have. Desiccant itself get evaporated into the flow of hot air, and itself flown to the exhaust, so that any impurities may be there that can also flown to the exhaust. So cleaning, dehumidification, and cooling operations can simultaneously occur with this integration, and it's a total process shown on to the psychrometric chart by its dehumidification and sensible cooling process by respective state point, so that two process air flow rates required. One is the process air flow for cooling and reactivation air reversibly for to maintain the drying operation. Otherwise, what happen? Will become saturated, and its operational effectively drastically dropped down to reduce the dehumidification rate. So this is how simple our desiccant innovative cooling system can work against the operation of conventional cooling. So a lot more benefits you may be available. Yes, here sometimes may not use any harmful refrigerant. So it is to be found environmental friendly green energy. So substantial potential energy saving has only limited temperature to be docked for the cooling. It required only 25% of the energy to be consumed by the conventional system. Source of the input thermal energy can be diversified here in the regenerator. That is to be solar, some industrial waste heat, or some low-grade thermal energy called the natural gas. Indoor air quality improve. One, it provides itself a cleaning, and other one, it may require low-cost cooling and dehumidification integrated operation, so that more and more mixed air, fresh air plus recirculated air can be flown through the system. So indoor air quality will be improved if we provide a mixes of ventilation air along with the recirculation air. Operation is at ambient pressure, nowhere very higher or lower temperature as compared to atmosphere is used in the system. All operation occur at nearly ambient. So far, material of construction, its operation and maintenance will be the simpler task as compared to the conventionally used HVAC. Desiccant system can be used in an alternate system by altering the configuration of a process as well as the regeneration air by altering its flow. So far used for summer or either the winter depending upon its configuration. So desiccant cooling can be the separate control of temperature and humidity. Humidity can only be controlled by the dehumidifier, while the temperature to be maintained alone separately by the cooling coil. So both of them things are separate. If your temperature system will be there, put off your cooling coil according to the thermostat signal to the system. If your dehumidifier operation is put off according to humidity achievement range of the supply air, make use of a thermo humidistat to close the wheel. So alternately ambient air to be passed through dehumidifier and cooling coil can be controlled in operation by the requirement. Here, if humidity range is there, but typically to meet the temperature, you may constantly keep on run the evaporator. But here it is slip condition, separable condition. Either of the component can get its put off operation according to need and requirement. Large ventilation airflow supply of fresh air will maintain necessary indoor air quality standard. Low grade heat can also be used instead of high grade electricity. It can couple to cogeneration system. If large waste heat to be used, can be used for regeneration. So there may be a couple to a cogeneration system for to maintain sustainable use of the energy. Reduce the size of the cooling unit, just you can say 1/4 of the total size, according to drastically drops down the cooling requirement, as the humidification task can get separately to be taken out with the dehumidifier. It almost operates its ambient temperature and pressure. So whatever may be the use of desiccant cooling can meet to the requirement of clean energy, clean technology, as well as the clean environment simultaneously to get through. There are number of desiccant material used according to its state as well as the application. There may be silica gel, molecular sieve. Some typical applications were listed, can be used in any part of world wherever ambient humidity may be the severe problem. So this is all about how the property of material to get selected as a desiccant. It should have a high moisture absorption capacity. All materials were not desiccant materials. Some fixed materials, what I have described earlier, can be selected as desiccant. It should have a capacity maybe around to absorb 10% times of its dry weight to its moisture. So typically in its principle, process air first pass to the dehumidifier, convert it to its dry, gets further cooled and to supply the room. And the regenerator may have provided the heat air for the reactivation of the dehumidifier. So liquid desiccant cooling and it's working. Material may be liquid desiccant coal as a lithium chromide, lithium bromide, calcium chloride, or triethylene glycol. So there may be a compartment called absorber column as well. Regeneration column is used. Room air may pass to the flow channel of the absorber. So downfalling absorber in liquid state get moisture out and convert it to weak solution from the strong solution, and rest dehumidify air will send to the further cooling. The same weak desiccant solution provided to the regeneration column for removing the water vapor by the flow of regeneration air from bottom. So as a exhaust air, moisture will be removed from the liquid desiccant, and strong liquid desiccant collected at the bottom of regeneration column and supplied back to the absorber column. Similarly, there is an alternate flow of strong and weak solution through absorber column to regeneration column, and dehumidified air itself pass through absorber column only, while regeneration air is limited to flow through the regeneration column. There are certain limitations of the liquid desiccant cooling, such as corrosion. Yet it working in the liquid stage may have certain times carry over by carrying the fumes of desiccant to the occupant. So most of time typically used only for the industrialized application. Yet its working sometimes to the low temperature can affect the crystallization formation at a low temperature for the desiccant material. So these are the various material used for the solid desiccant purpose, such as activated charcoal, silica gel, zeolite, calcium chloride, molecular sieves, as well as the metal silicate. Pictorial view will show the identification of the different desiccant in the industry too. This is the comparison performance chart for the use of different desiccant materials. So typically desiccant wheel is one rotary device through its section to be divided into the process air as well as reactivation air. So after dehumidifying, we may have to provide one sensible heat-to-heat recovery wheel for energy recovery that can increase the effectiveness by lowering the temperature at the exit of dehumidifier and increase the same to provide the heat or preheating the regeneration air supply to the reactivation site, so that the amount of heat source quality will be reduced. Different desiccant cycle based on the return room air is used or whether the fresh ambient air is used is called Pennington cycle or recirculation cycle. Sometimes you may use a combination of direct evaporative cooler for the cooling in case of desiccant. Sometimes some recirculation mode will be used. Partially the ambient air in percentage, you can say 5%, 10% get mixed with the recirculation air, and the same is get circulated through the system. So how we can compare the two systems in psychrometric chart? From the comparison, we may find certain benefits that red color here, red circulation can drop down a temperature to the lower desired value, and ventilation should have the requirement of low regeneration point as concerned to the recirculation system. So Dunkel cycle, some incorporation of more than one sensible heat exchanger, maybe a couple of direct and indirect evaporative cooler resulted to the big cycle. Sense cycle use of cooling tower and partially disturb the cycle for supplying air for the reactivation in the middle will also make a different comparison of different desiccant cooling cycle described on a common scale on the psychrometric chart. So you may see here certain cycles will be better at low maintenance temperature. Some cycles may be better to available with low regeneration temperature, but they have may certain added benefits and limitations. And according to the typical requirement, each cycle may be suggested for the typical applications. Sometimes what I have tell earlier, 100% recirculation air used. Sometimes it may be bypass of some of the air to maintain the high air flow rate. Sometimes certain post cooler and pre cooler may be used in the system. Sometimes mixing and both the pro cooler and post cooler will be used. Some of the data regarding to the actual measurements from the temperature as well as the humidity. Suppose we take the ambient temperature for some typical measurement is 32 degree. After desorption may rise to 50 degree. So heat recovery will put it to 24 and ultimately with the cooler can maintain to 60 degrees. Similarly, RH if suppose available 40% can lower to 9%, again can be increased 31%, and with the help of evaporator cooler to be maintained to keep the humidity ratio as per the comfort point temperature onto the psychrometric chart. Similar observations and notation you may have found for the regeneration circulation also. So these are the different kinds of chillers may have compare upon the depending of material combination. Sometimes instead of waste heat, condenser heat is used for to provide the desorption. Sometimes solar heat may be used, liquid to air heating coil incorporation for the purpose of dehumidifying. IC engine waste, diesel generator set waste, etc. may be used in some applications. So this is how a typical range of waste heat available in the different kinds of application, as well as the humidity drop within some range, as well as achievable regeneration temperature range to be compared for the different applications. So this is how we can compare a combination of a different dehumidification and cooling systems on the psychrometric chart. So yellow and vapor compression is to be used. You can have obtained 3.17 COP. If we use a combination of desiccant vapor compression hybrid cooling, then amelioration in the COP took place to some slight value. If we compare it to the evaporative cooler for some typical applications, may have get rise to the COP for the same system, maybe above the 4. So this is how we can get ameliorate the COP based on the typical configuration. This is so how the internally looks of the desiccant dehumidifier, its matrix, and how it get laden with the desiccant material to create a maximum surface area internally through the sinusoidal or honeycomb structure, so that maximum desiccant material can store within or lined within the fluids of maintenance. So this is typical applications where either the large area or the human occupancy, wherever desiccant cooling application will find it prolonged application, such as a supermarket, theater, hospital, hotels, office building, indoor swimming pool, pharmaceutical plants, central library, all that typical dehumidification as well as cooling will be required. They are the typical dehumidifier manufacturers in India abroad. So from you may collect or to make construct your wheel according to the requirement of your experimentation. So this is how typically the dehumidifier gets working. First of all, wet process air pass through the process air section, gets dehumidifier air and may be taken out. At the other end, regeneration air may be taken it, and at the other end, it may heated to a high temperature, may pass through the dehumidifier and get exhausted out to the other end. This is the internal look of the dehumidifier. I will have worked for my PhD at IIT Roorkee, how the drive mechanism is there, how some filters may be used to remove some foreign materials and particles to get flow through the system. So this is how the system is coupled and get integrated to the various other systems. So the height and size of the dehumidifier may be above the size and height of a common mat, depending on typical capacity and its application. So this is how the regeneration or reaction temperature may get affect the dehumidification rate in case of regeneration. This is the simulation chart will show you the operation of hybrid cooling system. Your test room will provide a return room air first to dehumidifier for the process of drying and dehumidification. Heat recovery will get it partially heat recovered to add to the opposite reactivation air to the reactivation airflow side, and remaining cooled air to be flow through the VCR cooling coil for the maintenance of temperature of supply air according to the room supply conditions requirement. The black color will show you the flow of refrigerant through the conventionally cooling mechanism, and blue will show you the flow of return room process here. In reactivation side shown to be of the red area. After passing through heater, required maintenance of temperature is to be made at the dehumidifier inlet to the regeneration side, and at the exit may flown to the exhaust. The size of wheel of dehumidifier is to be very less, around 20 rph per hour is very less as compared to the flow of heat recovery wheel as well as the other pumping mechanism. So these are the various instruments such as a pressure transmitter to know the pressure drop, temperature and humidity sensor, air velocity transmitter, humidistat, thermostat, etc. were used as well as the scanner to take the runtime simulation. Performance parameter, which are the parameters going for the study to measure the performance of the system, how the different parameters get affected system to its performance as well as regeneration to processes air area for the different dehumidification rate can get described. So some of the portion, as it is because of limitation of time, get skipped here. So this is the important timeline in case of inventions to various applications of the desiccant cooling and its simulation technique integration with the solar. The photograph is shown for the respected Carl Munter, who have get invented first desiccant laden rotor in the history, and his industry established to be still available in America, known as Munter's, and all its branches to the different parts of the planet. So how a different research is associated with the timeline range of the decade by decade progress in the desiccant based cooling gets highlighted over to the period of time. So different investigation technique to be used, experimental investigation, numerical modeling, transient simulation, artificial neural network modeling, and thermodynamic analysis. So we have typically, this is how we can set up the desiccant cooling. What I have prepared my time of PhD at IIT Roorkee, still available there as another researchers are currently going on his work. This is the test room we get selected, calculated load as well as the defined indoor condition. Uncertainty analysis for measurement uncertainty, different literature review will get performed. Some mathematical modeling will be done to predict the performance of dehumidifier prior to its working. Some transient simulation has been performed to the developed system to measure its variation in temperature and humidity over to the period of cooling period. Some artificial neural network modeling can also be done previously to estimate the experimental data, which is not going to be performed by analysis. So here our discussion of topic is also related to the Exergy analysis. So with picture, that is self-explanatory. What is energy? How it's resulted to the entropy, and how much useful energy can be termed as a Exergy. So Exergy is nothing but as a to be defined and explained in a very well in the previous lectures. So exergetic efficiency of the system described today here can assess individual performance of the different components used in integration form for performing the system. It's also see the potential improvement in the function of its individual system. The analysis also helps in identifying and quantifying the area for minimization of Exergy losses, as well as improving the performance of the system. So how Exergy can be defined in a very literal way by consideration of the entropy generation. Common formulation can be applied for the entropy generation for the different primary component called desiccant wheel, sensible heat wheel, sensible cooling coil, as well as to the heater based on its measurement of law of process, as well as the regeneration year, as well as the enthalpy determination. So Exergy efficiency to be determined based on this formulation derived to be for the dehumidifier, heater, heat wheel, as well as the cooling application. So this is the table. How can we compare Exergy destruction as well as Exergy efficiency for the different applications? So with the pie chart, you may have compare maximum destructions can be occur with the wheel, later on be heater, then to the heat recovery wheel, and at the end be cooling coil. So we also get our exergetic efficiency results to be performed over to the different components, get to be validated with the system to be developed by Canogluetat in 2004. However, system predicted the RP ratio for the variation in exergetic efficiency for the different regeneration year to be started from 120 to 135 for the variation in ambient temperature as well as the regeneration temperature, how it can get impacted to the Exergy efficiency of the system. What will be change in the Exergy efficiency if we use evaporative cooling as far as we are using conventionally vapor compression based system can get compared by the use of the psychrometric chart for the system used. However, HVAC system in terms of desiccant cooling and humidification find its overall Exergy efficiency and its a comparison with the different other established HVAC system. So you might have find its result to the top and better one as compared to the most of the other absorption based cooling system. So in our system we may have found overall Exergy of the system to be in 11.45% and dehumidifier will find it Exergy efficiency to be 74, heating system to be 53. Our analysis show that desiccant dehumidifier and regeneration heating system can contribute measure to the entropy generation, and Exergy efficiency of the system can be increased by minimizing the Exergy destruction that related greatly to the available temperature range for the heater. And so far, as we see here, most of time the desiccant which will gets humidify potentially to ambient temperature will reduce the availability and requirement of maximum temperature as well as the pressure to keep down the heats and heating requirement for the reactivation, and that it will save the energy as well as increase the exergetic efficiency of the system. So currently researchers are in invented phase to determine the desiccant which will cools and humidify to be at very low temperature nearer to ambient 40 to 45 degree centigrade, so as to meet this application of desiccant cooling to bring amelioration of the comfort, energy, and cost saving to the human beings. So there are some of the ready reference books are also available for the detailed study and experimentation of the system. Further, I am very thankful to all of you for getting me listen over to the period of time, you can say around and over 90 minutes. Now I stops my presentation and open up my session for debate, discussion, and questioning. Anyone having the question, any doubts, any difficulty, I will have now open up the session for question answer for next 10 minutes so that we can conclude our session exactly around, you can say 11:30, that is to be in time. Thank you, friends. I am also thankful to the Kingston College of Engineering for providing me a great opportunity to put my knowledge to great number of the researchers and partners and researchers so that potentially as they may relate to the sustainable and green energy will contribute a lot to the benefit of human being in the coming days. Thank you, sir.
Sir, can I ask a question, please?
Yes, yes, definitely. You may ask her. Unmute yourself and to ask me question.
I like to know how the this dehumidification temperature of desiccant material can be determined.
Dehumidification temperature of the desiccant can be determined on various aspects: rate of dehumidification, material density, whatever may be the volume of desiccant used with the same hill, whatever may be the internal channeling, may be of square, triangular, hexagonal, or sinusoidal. Most of time, hexagonal channels and sinusoidal channels are very common with the materials, that it can integrate most of the desiccant with the same size and surface ratio. Different desiccant material having, sir, by nature different regeneration temperature. In a tabular form earlier, we may see that different desiccant can get efficiently regenerated at different temperature.
Okay, so what is the effectiveness generally of a desiccant wheel?
Desiccant will effective wherever we got our transit simulation modeling, we are predicting it to be 85 to 90, and then after we'll get our system to be simulated, and finally effectiveness to be determined within that range, sir.
Okay, sir. Thank you, sir.
Okay, thank you, sir. Any more friends required to know? In the same field, I will have my 6 research scholar in PhD. The work is going on for the different. Yes, I invited Dhiren Kumar sir for unmuting from the organizer as he have some question. Yes, sir, you are definitely asked. Dinesh Kumar sir. Dinesh Kumar sir, you are invited to ask the question. I request the organizers to unmute Dinesh Kumar ji for to get its voice. Organizer sir, Dinesh Ganesh sir.
Yes, yes, sir. Yes, actually,
Yes,
Dinesh
please
sir.
unmute Dinesh Kumar sir so that he may ask. He's a rise hand.
Sir, I think it is not. He is not finding any questions.
Okay, okay, no problem. Yes, his hand is up. That's
If you have any questions, you can interact with our resource person. Thank you.
So topic is very vast, friend. Within 1.5 hours, it is very difficult to get through. But I try my best by keeping initial introduction to be very detailed. Because if you not get through the operation, so it is very difficult to get through the rest of the obtained result. So that I dedicatedly involved 1 hour for the introduction and as how the desiccant get its entry in the dehumidification and cooling. Yes, sir. Sanjay Kumar, sir.
Hello, sir.
Yes, sir. Yes, sir.
Myself, Sanjay.
Yes, sir.
Can you hear my voice loudly and clearly?
Yes, sir. I am clear your voice very loudly. No problem with
Sir,
your voice.
okay. First of all, your presentation was very fantastic one, and
Okay,
yes, it would be a great help for our future studies if you just could share the presentation file in PDF format or
yes,
so.
sir. Yes, sir.
Okay.
Yes, sir. That I provided
See,
to the organizer so that
uh,
you can get it later. And one more
because
thing I want to add it, if
hmm,
people from South want further knowledge regarding to the person and the
hmm,
people and some setup, that setup is in large number available at Indian Institute of Technology, Chennai, where renowned professor, very Indian continent and world expert, Dr. Prakash Maiya sir is there. So you may anytime contact Prakash Maiya sir. He is the father of desiccant cooling from the southern area. So he is very expert as well as gone through many experimentation and number of PhD student work under him. So sir, you may contact to MP Maiya sir at IIT Chennai too, as it is in your region, sir.
Okay, sir. Okay, please provide the contact number with the organizers, then we will get it
Okay,
back.
okay. I will have provided my contact number and all. Prakash Maya sir, I will also add details to the organizers so that they may share it with the participant.
Sir, okay, sir. This my question is regarding
Yes,
the
yes.
test setup you have you had constructed for the work of your PhD at I think IIT Roorkee.
Yes,
You also showed a couple of photographs of that.
yes.
Just out of curiosity, I would like to ask that you have conducted many tests, no?
Yes, I have conducted 3 years test during my PhD
Uh,
from
uh,
2012 to 15 for that setup, sir.
Okay, okay. My question is regarding energy recovery wheel or enthalpy recovery wheel,
Yes,
heat
yes,
recovery wheel,
yes,
solid desic, yes.
yes, sir.
Generally, what I see is calculations are done for steady state. Uh,
Yes, sir.
Steady state. Okay. As you have already conducted physically, you have seen the tests. Okay.
Yes,
My
yes, sir.
question is, how in practice, how much time it takes to reach the steady state? Let us say
It may
for
take around, sir, time from 0 second to, you can say, about 30 minutes to reach its steady state. More or less, it will depend upon temperature also, because temperature is also
yes,
the dominant factor to affect the
yes.
pressure. Wherever temperature increase, you may see during summer pressure
Mhm,
goes down. When temperature reduces, pressure goes up. So it is a critical factor, humidity and temperature, to meet the steady state requirement. We may also done transient simulation with the help of transit simulation for a second
mhm,
to you can say for 15 minutes, how the dehumidification can start
mhm,
it and get initiated and reach to its steady state.
mhm. Yes. And just let me know up to what maximum level of airflow you have tested? Airflow
I have
of
tested from zero point 0.5 to 2.5 meter cube per second air velocity.
2.5 meter. Okay.
Or 2.5 meter per
And
second.
how much phase velocity you could achieve in actual test setup for recovery wheel?
Yes, sir. Recovery wheels are whatever may be the velocity around 2 meter per second is to be most of time used because of pressure drop. Wherever you provide 2.5 meter second to desiccant at the exit
Mhm,
side, because
mhm,
desiccant is a fluids that can be made with the matrix. So whenever air is passing through it, obvious the pressure drop must be there. So based on that, whatever may be the velocity considered to be different for a different component. Once again, air has to pass through the, you can say, the matrix of air heat recovery wheel. Yes, it is not having laden with desiccant material, but can be the matrix of metal alone. So part of cycle, it gets heated during its rotation, and part of cycle, wherever it flows to about reactivation air, gets cooling. So it's obvious that heating and cooling operations will be different for the flow
mhm.
of air through process air section or regeneration air section.
Yes, yes, absolutely. Okay,
Yes.
okay. These were just preliminary questions.
Okay, no
Just
problem,
wanted
sir.
to know out of
Further
curiosity.
discussion will be
If any,
possible with my phone
yes,
number if you have any doubts further.
please, please, sir. Okay, we would be
Okay,
very
okay,
pleased with
okay,
that.
sir. Thank you, sir.
Okay, thank you, sir. Thank you.
Thank you, sir.
Hello, sir. I have a question.
Yes, sir. Please speak.
Sir,
Louder, sir.
when we humidify the air and we are
Yes,
getting the
sir.
moisture, so we
Yes,
are
sir.
just wasting that moisture, or we can use that moisture somewhere else also.
That moisture is retained by the surface of the desiccant material. It gets condensed so that in dry condition, after the dehumidification, adsorption, that will become wet. So that material gets its saturation condition. No further dehumidification will be possible. At that time, you may want it regenerate flow of hot air so that that moisture will taken out from that wheel surface to make it dry. And again, more moisture during dehumidification can get condensed. So this is the mechanism. How can we use the moisture flow from process air to the exhaust?
Okay, sir.
Okay. participants were invited to clear your doubts and difficulties, if any.
Thank you, Dr.D.B.Jani, sir,
Thank you,
for
sir. Thank
enlightening
you,
us
sir.
on the topic of XSG analysis of HVAC systems in power generation. As we say, conclude that no queries from participants.
Okay, thank you, sir.
We conclude now the session. Resume at 12 p.m.
Okay.
So all dignitaries are requested to present by 11:50 a.m. Thank you.
Okay, thank you, sir.
Thank you, Jani sir. Thank you.
Okay, thank you, sir. Thank you. Goodbye, sir.